We're going to be talking about how to create reproducible reports with R. My name is Braulio Cuandon. This is my partner, Alyeska Santos. I'll be going over the scenario, the regulations, the restrictions, and the goals we faced in this project. Anna will be going over the program itself, and the program features. Just a little background, we work for BWI, and last year around January, July, we were tasked with creating an R program that can write engineering reports for engineers. A bit more background. So BWI, Biosense Webster, is a leader in the science of diagnosing and treating heart rhythm disorders, specifically AFib. AFib can lead to strokes, heart failures, and blood clots. And since we develop a product that comes in contact with the heart itself, we are heavily regulated by the FDA in the documentation section, specifically our reports. We have strict guidelines to how our reports are composed and presented to the FDA. BWI itself generates about over 1,000 reports a year. Each report takes about 4 work days, so that's a total of 32 hours. So just doing quick math, 1,000 reports, 32 hours, let's say engineer 1 makes about 25 bucks an hour. It's a lot of money and time wasted. So we wanted to eliminate all that. However, due to how strict our procedures are, and our methods are, we have very strict regulations when it comes to writing the report itself. So strict that even minor errors or deviations from our templates often result in rejections. This is actually an example of a report we generated with our program. As you can see, it looks just like a regular Word document, which is great because that's what we were aiming for. We wanted to pass through our documentation system without any kickback, and we could not do that with HTML or PDF, so we had to rely heavily on the Word format. We did manage to get about 2 reports into our documentation system without the approvers themselves noticing that this was an R-generated program. We do have certain regulations we had to follow. For example, all our reports are required to have a cover page, and in that cover page, we are required to have a title, the location of the document, the author's name, and the date it was generated. In our headers, we're required to have our logo, the test being the test study, the title, the number, the revisions, and the pagination. Like, all this is really hard to do with Word, and we had very, very many setbacks with this. Moving towards the body, we do have regulations on our headers. They must be numbered in sequential order, and certain sections must contain specific content. We also had regulations with our table. All the headers should be highlighted in gray for the reviewer could see the difference between headers and actual data. We also had regulations that came to our stat methods. This is an example of a process capability. Whenever we do histograms or process capability studies, we are required to show the CPK. Anything below 1.3, we're supposed to generate a rationale on why it's allowed. Just a quick walkthrough for our life cycle of a report. So like I said before, it takes about 4 days to generate a report. And after we generate a report, we send it out for approvals. From then, it takes about 2 weeks to hear back from our approvers. Our approvers are really busy. They're usually higher level engineers. So taking about 3 hours of the time to review our report is another money pit. And if they find anything, they're going to reject it, kick it back, and we have to redo the process. We have to spend about another 2 hours of their own time and our time to fix any issues, and then the cycle begins again. You could see after constant rejections how many hours of the day and how much time we waste with just writing a simple report. These are some kind of errors we usually find. People will be using the wrong kind of template. For example, someone used a Rev G version of the template instead of the newest Rev H. This is very common since our engineers like to get previous approved reports and modify them for their studies. This is another example. They often, when they revise previous reports, they don't verify if they changed all the product names or if there's any contradicting statements. For example, we're talking about catheter body in the purpose, but in the scope, we're talking about catheter tip. That's a contradiction that will get us in trouble with the FDA. We're also talking about 32 samples, but in the acceptance criteria, we only have about 30. There's also inconsistency with our lot numbers and our units. All right, so some restrictions we faced is our rigid system. We had to follow our template to the T, or else it would get rejected, and we have to lose more time making a report. The second one is we have to submit it in a Word document. Using R with Rmarkdown with Word was one of the biggest hurdles for us. A lot of the packages do not work with Word output, so we had to figure little tricky ways to get around it. Our overall goal for the project was 1, eliminate as much of the time possible it takes to generate a report. 2, make it super simple that could be done in 1 click. 3 was review the user's input to make sure there's no mathematical errors, no grammatical errors, or any stat errors. Then finally, our last goal was we want to make this program flexible as possible to be used for a variety of tests. We did not want a one-trick pony report. I'm going to hand the mic over to my partner, Alyeska Santos, who will be reviewing the program and the program features.
Thank you. So, as you can see, you have found how cumbersome it could be to make the reports. So, what approach did we do to actually improve this process? So, first, we specified the reference document within our YAML header. The reference document would serve as the backbone of the rest of the documents that we are going to generate. And within the styles of the headings in the Word document, what we did was to edit the headings. For example, we wanted to edit the font, the color, the size, and the indentation. That way, we could mimic how the text are supposed to be shown within the specified procedures within our document system. We also specify that Word document, of course, is what we wanted as an output, because this is the only type of document that is allowed within our document management system. Now, as much as we wanted to standardize the report generation procedure, we also wanted to give our users the flexibility to actually be able to customize their reports in their own ways, because each engineer does different types of testings, and this would require different types of analysis. So for this one, we require them to input a raw data spreadsheet, which includes the specifications of the testing that they have performed. We also have text input sections where we could capture the details of the title of the testing that was performed and who is the author of the report. Also, to give them a flexibility when it comes to analyzing, we let them choose from a pool of options of what types of plots they are able to show. And with that, I mentioned earlier that users are required to input a raw data spreadsheet. Now you're going to ask, what are the typical things that are within the raw data spreadsheet? So this is an example of a toned down raw data spreadsheet. And within here, the specifications of the testing is shown, such as the title of the testing that was performed, what are the steps that has been done in order to follow the procedure of the testing. And in here, we could see the values that were gathered within the testing that has been performed, and also the bounds on which or wherein the measured data should fall into. And within this raw data input, what we do is check the data for any types of inconsistencies. Let's say there's inconsistencies within dates. We are trying to catch that early on. That way it doesn't get escalated into a higher level problem. We also look into the errors within grammar and spelling. And also we look for drastic outliers, because we wanted this to be a potential problem in the future if it's just a little typographical error. And also, sometimes our engineers are rushing their reports, furiously typing, and sometimes accidentally they hit the caps lock on. And we don't want it to be shown in the report, because what we wanted to show is something in title case as shown in the photo below. So stringer is really helpful to do that. The functions string to upper and string to title helps us to be able to control this user inputs. Now, the report generation procedures using R and having it in a reproducible manner was never easy. There's a lot of things that are hurdles along the way. So the first one is that the Word document headers were a little bit difficult to edit, especially if you wanted the text to appear dynamically as the users input them. And there's also hurdles within actually outputting the tables that are following the specific procedures that was outlined within our documents. And also having users with different backgrounds, different locations, be able to access this change within the process of generating the reports. And also, lastly, for users to further be able to customize the reports that they're trying to make. So how did we edit the Word document headers based off the user's inputs? So what we did is we have a reference document wherein we have keywords. As you can see, the second photo has quadruple X. So we wanted to edit the quadruple X with the user input. So packages officer is really helpful for this. Specifically, the headers replace all text function. What it does is it looks for the keyword, and this keyword is replaced by the input, which, for example, is catheter tip diameter. And then with this print function will save this in a specific path, and this will be the reference document that will be specified in the YAML header. That way, going forward, all the documents that will be printed by the user will be as such, because we wanted these titles and revision levels to appear in the actual output. So now, as specified earlier, there's specific formatting that has to be followed when it comes to the tables that we're trying to generate. And officer and flex table was really useful for such, because we were able to make beautiful tables and actually output it in Word. And Pandoc is definitely essential for having this done, because it gives us a success to be able to output it in Word. And another feature that we like the most with officer and flex table is the style function, wherein we could add a conditional statement. So within the conditional statement, what we do is the measure data, which in this case is tip diameter. We look if it is below the lower specification limit or above the upper specification limit. And if it does, then we wanted to highlight it, because this is probably a potential type of concern that we wanted to address early on. So what we do is we change the text of the color in red and also italicize the text. That way it catches the user's attention. And then going forward, we wanted people within the company with different backgrounds, different skill sets, and different locations to be able to access this type of methodology. So with that, we decided to leverage the Johnson & Johnson's Shiny server. And within that, we deployed a Shiny app that has this Rmarkdown wrapped. And with this, it allowed for users to access it within a web link, put their inputs, and once they hit generate report, they could automatically have the report properly formatted within their downloads folder. Also, we were able to add more features for further customizations of the plots that the users want to actually generate. So for example, here, if the user uploads the raw data spreadsheet, the column headers within the raw data spreadsheet is red. And once this is red, the drop-down menus for the scatter plot x-axis and scatter plot y-axis is automatically updated with the column headers. Why do we want this? It's because like the raw data spreadsheet column headers could be edited by the users, and we want them to be comfortable as possible and easy for them to be able to generate these plots. This is an example of a plot that was generated by the user. Now we showed you little snippets of how the report looks like by going over a few of our methodology. Now, as an icing on the cake, we want to show you an example output. Keep in mind that these are not actual data, and it's only used for demonstration purposes only. So that is the title page with the title and the author name. We have the sections with the subsequent parts of the sections properly indented. We have tables. We have the table for equipment. We have procedures that are shown sequentially. we have the failure highlighted in red within the raw data table. Then we have more observations, as you can see. And then further down the document, we have scatter plots. We have box plots with the failure highlighted in red, as shown as the outlier. We have normality plots. We have capability histograms, and the table below that shows capability measurements that were also calculated. And also below, we could see, for example, the recommendation, and then the subsequent paragraph that is in the introduction of the section is properly indented, and then the actual recommendation is further indented. So these are the little things that we made sure is also captured. Now, what do we want you to take away from this presentation? You may think that the methodology shown might not be as complex, but the key idea here that we learned along the way is we wanted to challenge all of you. We wanted to challenge each one of you as you go back home through your individual organizations. Like, we want you to promote the idea of reproducible data analysis with your individual organizations, because along the way we've seen how it is important within a company. We wanted you to be able to eliminate documentation errors, and once you do that, you could actually be able to focus on higher level issues. Also, this is just one application of reproducible data analysis, and we know that on your different job functions, you could also implement such methodology. And lastly, once you are able to successfully deploy such, I think that you could eliminate bottlenecks within your own systems. And for us gathered here today, I think if we free up some time within our own day-to-day work functions, we could write more scripts, we could deploy more applications, and I think that is a win-win situation for all of us. It's an investment that we're making for further down the line. Lastly, we would like to thank the following people for their time and assistance for this project. Thank you. And yeah, thank you.
All right, we have 3 minutes for questions here, so let's tackle a few of these real quick, if I can pull them up. Have you tried out the GT package for custom tables? Have you heard of that package?
Is this a relatively new package?
I don't think it's on CRAN yet, but it is a new package that's out for creating custom tables.
No, but we might
No, we
want to check it
haven't,
out.
but we will check it out.
Yeah, yeah. Second question is, how much iteration has this project required? That is, are reporting requirements subject to change?
Yes. It's not as often as as you think. I think every year to half a year, we get a new update in the documents. The changes are minor, so we just have to change the code slightly to fit the new template.
Fantastic. All right. How were the process control charts produced? Custom package? Do you know?
For the capability histogram, the library, the package GGQC was used. And then the process capability measures is coming from another package that, I'm trying to think about it. Capability tools? Yeah, I mean, whoever asked that question, if you connect with me, I could get back to you.
Fantastic.
Sorry about that.
One last question here. Once you put the report in Word, how do you handle changes to the document? How do you incorporate feedback edits to the Word doc back into our Markdown?
Sorry, the previous question, I just remembered the package. The package used to calculate the process capability measures is QCC.
QCC,
Yeah.
okay. So last question here real quick. Once you put the report in Word, how do you handle changes to the document? And then they have a second question. How do you incorporate feedback edits to the Word doc back into Markdown? Does that make sense?
So if they're asking about the feedback of the approvers, so basically the approvers would put a note within the document management system, and since the output is in Word, it gives the flexibility for the actual author to be able to edit it. But the users don't have access to the Rmarkdown file itself. It's only the programmers who have access, if that answers the question.
They do have the capability of emailing us, and we could make those modifications to fit the overall report better.
Because
Fantastic.
what we also wanted to control is users trying to favor themselves in the creation of the reports. That's why we still wanted that control.
Got it. All right. Well, thank you. Let's give him a hand. Thank you.